Let us study about the structure of carbonyl group. In a carbonyl group, the central carbon atom is bonded to oxygen by means of a double bond, while the carbonyl carbon is attached to two other groups by means of a single bonds. Both the carbon and oxygen of carbonyl group are sp2 hybridized and has got a bond angle of 120 degrees. As both the atoms of carbonyl group are sp2 hybridized, the carbonyl group possesses a trigonal planar geometry. Here, all the atoms or groups around carbon atoms lie in one plane, that is, in the plane of paper. Both the carbon and oxygen of carbonyl groups contains p orbitals with one electron each, which are lying perpendicular to the molecular structure. Let us discuss the orbital view of carbonyl group. The carbon of carbonyl group has got a ground state valence electronic configuration of 2s2 2p2. In the excited state, one of the electrons of 2s orbitals is promoted to 2pz orbitals as shown. Now, one 2s and two 2p orbitals of carbon undergoes hybridization and thereby result in the formation of three sp2 hybrid orbitals as shown. Similarly, in carbonyl oxygen with the valence electronic configuration shown, one 2s and two 2p orbitals hybridize and thereby results in the formation of three sp2 hybrid orbitals. It may be noticed that two sp2 hybrid orbitals has one lone pair each, while the third sp2 hybrid orbital of oxygen lying in close proximity to carbonyl carbon has got a single electron. Now, the closely aligned sp2 hybrid orbitals of carbon and oxygen undergoes end-on overlap and thereby results in the formation of sigma bond. The two sp2 hybrid orbitals of carbon are bonded with carbon atoms of two alkyl groups R and R' via sigma bonds. Further, the unhybridized and perpendicularly arranged p orbitals of carbon and oxygen atom having one electron each involves in sideways overlap and thereby results in the formation of a pi bond. The carbonyl group may also be visualized as shown by figure 2.